This is lesson 3.1, graphing linear equations in two variables. Our learning objectives are to plot points in a rectangular coordinate system, graph a linear equation by plotting points, graph vertical and horizontal lines, find the x and y intercepts, and graph a line using the intercepts. So let's begin by talking about plotting points in a rectangular coordinate system. Now, the rectangular coordinate system is formed by two intersecting number lines, one horizontal and one vertical. The horizontal number line is called the x-axis. So here's the x-axis, horizontal number line. The vertical number line is called the y-axis. So here it is, boom. These axes divide a plane into four regions called quadrants. The quadrants are identified by Roman numerals beginning on the upper right and proceeding counterclockwise. So here's quadrant 1, top right. Here's quadrant 2, top left. Here's quadrant 3, bottom left. And here's quadrant 4, bottom right. All right, let's talk about ordered pairs. An ordered pair, x comma y in parentheses, gives the coordinates of a point in a rectangular coordinate system. The first number is the x-coordinate. The second number is the y-coordinate. All right, so when x is positive and y is positive, that puts things in quadrant 1. When x is negative and y is positive, that's what puts a point in quadrant 2. When x is negative and y is negative, that puts the point in quadrant 3. And when x is positive and y is negative, that puts the point in quadrant 4. Great. The first number is the x-coordinate, the second number is the y-coordinate, right? So whenever you write an ordered pair, make sure to put x first and then y second. It helps things stay organized. X always goes first, y second. Now, let's talk about the origin. The origin is a special point. It's the point 0, 0. It is the point where the x and the y axis meet. All right, so here's 0, 0 right here. And points on the axis. Points with a y-coordinate equal to 0 are on the x-axis and have coordinates a, 0. Points with an x-coordinate equal to 0 are on the y-axis and have coordinates 0, b. Well, who created this coordinate system in the first place? The first person to think of representing two-dimensional space like this, his name was René Descartes. He was a French mathematician who lived in the 1600s. And not only did he learn, invent a way to create two-dimensional space, he actually created a three-dimensional space representation. So he created a third axis called the z-axis. And that z-axis, see, it would come out of the center right here. It would create a third dimension. And so now he could represent three-dimensional space. You would talk about that in a future math class. Here we go. Let's talk about example 3.1. So it says plot each point in the rectangular coordinate system and identify the quadrant in which the point is located. So we see the first point, and it's -5, 4. So -5 is the x value, 4 is the y value. And so starting at the origin, we would go 5 units to the left. So here's the origin. I'm going 5 units to the left because it said -5, and then 4 units up because it's +4. That places the point in question right here. And so I will plot that point. Okay, and then I think for a second, which quadrant is this in? Well, that's in quadrant 2. And that makes sense because x is negative and y is positive. Moving forward, let's go ahead and plot another point, like -3, -4. So we start at the origin, and we look at the x-coordinate value, and it's -3. So we go 3 units left, and then we see the y value is -4, so we go 4 units down, and here is the point location. So plotting that point, I observe that point is in quadrant 3. So I'll write Q3. Next, we've got 2, -3. So starting at the origin, we move 2 units to the right in the x direction and 3 units down in the y direction, and this would be the location of that point. 2 comma negative 3 is right here. That's in quadrant 4. Next, we now see 0 comma negative 1. So starting at the origin, I move 0 units to the right or left. And I move 1 unit down, and this is the location of that point. And so I draw that location. And which quadrant is this point in? Well, if it's on one of the axes, like the x or y axis, it's in none of the quadrants, okay? So it's not in a quadrant, it's on the y-axis. So that's what I'll write. I'll write y-axis. So the only points that aren't in a specific quadrant are ones in which there is an x or y value of 0 in the point. That's a dead giveaway that it's on the y-axis in this case. And let's go ahead and look at the last point, 3 comma 5 halves. So let's start at the origin, and we're going to go 3 units to the right, and we're going to go up 5 halves. So 5 divided by 2 is 2.5, so we're going to go up, 2 and a half. And so our point would be right there in space. And so let's go ahead and draw that. So that point, has a fraction for the y value, and that's why it's between the lattice points. Now, that is in quadrant 1. All right, so we have now drawn all of the given points in the rectangular coordinate system, and we have listed which quadrant they are in. Let's go ahead and move forward, and we are going to give some new definitions. Let's begin with standard form of a linear equation. So an equation of the form ax plus by equals c, where a and b are not both 0, is called a linear equation in 2 variables. It's called a linear equation because the highest power of the 2 variables x and y are both 1. Their power, their exponent is 1. It's x to the first and y to the first. Okay? And something important to note is we've got 2 variables that we're dealing with, x and y. Now, a, b, and c, they will be coefficient values, right? A is the coefficient number that goes with x, b is the coefficient number that goes with y, and c is the constant coefficient. Now, how do we solve a linear equation in 2 variables, right? So if we solve it, the solution of that linear equation in 2 variables would be an ordered pair, like we just talked about above. It would be x comma y in parentheses. Now, it's a solution of the linear equation, ax plus by equals c, if the equation is a true statement when the x and y values of the ordered pair are substituted into the equation for x and y. Now, the graph of a linear equation, ax plus by equals c, is a straight line, okay? Now that's why this is called a linear equation, because when we graph it in a 2-dimensional space, it will form a straight line, okay? Every point on the line is a solution of the equation. So moving into a new example, example 3.2, the graph of y equals 2x minus 3 is shown. For each ordered pair, decide, is it a solution to the equation? Is the point on the line? Well, let's begin with the first point. All right, so we have 0 comma negative 3. Let's plot it. Starting at the origin, we go 0 units to the right or left and 3 units down, and we find that point is right here, which happens to be on the line that is graphed. Okay, so is 0 comma negative 3 a solution to the equation? Yes, because it's touching the graph of the line. Okay. Now, let's go ahead and move to B. Well, point B is 3 comma 3. So always starting at the origin, I would move 3 units to the right because x is 3, and 3 units up because y is 3. And there's where my point will go. And that is also a point that is on the graph of the line. So I'm going to say yes, it is a solution to the equation because it is on the line. Next, we've got 2 comma negative 3. Starting at the origin, I go 2 units right, I go 3 units down. Here's that location in space. Is 2 comma negative 3 a solution to the equation? No, it's not on the line of the graph. All right? And lastly, D, negative 1 comma negative 5. Starting at the origin, I'm going 1 unit left, 5 units down, and I see this point right here in space. Let's plot it. And that is on the line. So I'm going to say, well, yes, it is a solution. Great. So we can take any xy coordinate if we have the line graphed in space, and we can just plot the xy coordinate and see if it's on the line. If it's on the line, it's a solution to the equation that we were given, right? Y equals 2x minus 3. And if it's not on the line, then it is not a solution to that equation. Okay. Now, we just saw a line that was graphed for us. And so the question comes up, how do we graph a linear equation? Well, let's show you how to graph a linear equation by plotting points. Here's a quick step process. So step 1 of how to graph a linear equation is find 3 points whose coordinates are solutions to the equation. Organize them in a table. Step 2, plot the points in a rectangular coordinate system. Check that the points line up. Step 3, draw the line through the points, extend the line to fill the grid, and put arrows on both ends. Great, I'll show you how it's done. So let's say I have to graph the equation y equals 2x plus 1, right? Example 3.3, graph y equals 2x plus 1 by plotting points. So we're going to choose some x values and put them into this table. Now, the easiest x values to choose, just right off the bat, we're talking about a linear equation. If I were you, I would choose -2, -1, 0, 1, and 2. These are 5 fantastic points to choose. These are x values that are close to the y-axis. It's -2, -1, 0, 1, and 2 that I'm choosing. Now, you're the one who chooses the x values that you're going to plug into the equation. So you can adopt my method of choosing those 5 values. Now, our equation tells us that y equals 2x plus 1. So I'm going to plug the x values in for the x in that equation, right? So I would have 2 times -2 plus 1, and then 2 times -1 plus 1, and then 2 times 0 plus 1, and then 2 times 1 plus 1, and then 2 times 2 plus 1. Great. So I have just plugged in these x values for x in the equation. So those x values go right here. And now let's go ahead and clean it up a little bit. So we'll get a simplified value. Now, 2 times -2 is -4, and -4 plus 1 is -3. 2 times -1 is -2, and -2 plus 1 is -1. 2 times 0 is 0, and add 1, that's 1. 2 times 1 is 2, plus 1 is 3. And 2 times 2 is 4, plus 1 is 5. Now I have xy coordinates. They are -2, -3, -1, -1, 0, 1, 1, 3, and 2, 5. I can plot them on my graph. Let's start with -2, -3, and then -1, -1, and then 0, 1, and then 1, 3, and then 2, 5. Now, you'll notice that all 5 of these points they're in a straight line, okay? So at this point, what I can do is draw a line that goes through all of these points. And then I always extend to the ends of the graph and draw a nice clear arrow. Okay, so we have graphed the equation y equals 2x plus 1 by plotting points. Now, you'll need to pick at least 3 points, right? So you need at least 3x values to be able to graph the line. I went above and beyond. I chose 5x values. Okay, let's go ahead and move to the next example. So here we're going to do the same process again, but we have a different equation. Our goal is to graph y equals 1/2 x plus 3, right? So one thing we noticed, the coefficient multiplying x is a fraction. So let's go ahead and pick some x values so that we can plug them into the equation. And you guessed it, I'm choosing -2, -1, 0, 1, and 2. And I'm going to write the equation out, right? So this expression, 1/2 times x plus 3 is what y is. So I'm going to put 1/2 times -2 plus 3, and then 1/2 times -1 plus 3, and then 1/2 times 0 plus 3, and then 1, and then 2. Great. Now, let's go ahead and clean it up and see what those values are. So 1/2 times -2 is -1, -1 plus 3 is 2. 1/2 times -1 is -1/2, -1/2 plus 3 is 2.5. 1/2 times 0 is 0, and 0 plus 3 is 3. You might see a pattern emerging, right? So we're going up 1/2 at a time. So you can see 2, 2.5, 3. We can assume this will be 3.5, and it is. 1/2 times 1 is 1/2, and then add 3, that's 3.5. And then 1/2 times 2 is 1. 1 plus 3 is 4, which makes sense. And so now let's go ahead and plot these points on our rectangular coordinate system. So the points are -2, 2, and -1, 2.5, and 0, 3, 1, 3.5, 2, 4. That's what I'm graphing. -2, 2, -1, 2.5. There it is right there. 0, 3, 1, 3.5, and 2, 4. All right, so here we see those dots. They line up very nicely, which makes sense because we've got a linear equation. This is a linear equation, so we expect a line to be formed. And so now we draw a line straight through those points, and we see that line ends up looking nice and straight like that. And we draw arrows at both ends. This extended through the whole graph, and we are done. We've graphed that line. Moving forward, our next objective is to graph vertical and horizontal lines. Okay, so a vertical line is one that goes straight up and down. So just vertical line, right? Horizontal line is one that is just completely flat, going sideways. Okay, so we're going to talk about how to graph vertical and horizontal lines. Now, let's define them first. So a vertical line is the graph of an equation of the form x equals a. It passes through the x-axis at a, 0. A horizontal line is the graph of an equation of the form y equals b. It passes through the y-axis at 0, b. So when you have a vertical line, it will look like this: x equals a number, okay? And you go to the x-axis and you go to that number on the x-axis, and it will go through that spot. Okay, now a horizontal line will look like this format: y equals some number. And you go to the y-axis, to that number on the y-axis, and that horizontal line will go straight through that location. Let's look at some examples, and you'll see how easy it is to graph a vertical or horizontal line. So let's start with example 3.5, and we're going to graph x equals 2. Okay, so we go to an x value of 2, right, on the x-axis, and we plot that point. And now we draw a vertical line that goes through that point. These are all of the values for which x equals 2. So, different y values, but x is always 2 for that vertical line. Now, what if we're talking about a horizontal line? So if I see y equals a number, I go on the y-axis to whatever that number is. Oh, on the y-axis, I'll go to -3. And now I will plot the point, -3, and I will draw a horizontal line that goes through that point, like this. And we have now graphed a vertical and a horizontal line. In this case, x equals 2 was the vertical line in blue, and y equals -3 is the horizontal line in red. We'll give you one more practice. Okay, so x equals -4. I'm going to go on the x-axis to -4, and I am going to plot a point there, and then I'm going to draw a vertical line that goes through that point. This is the line x equals -4. And now looking at y equals 2. On the y-axis, I'm going to go up to a value of 2 from the origin, and I'm going to plot that point, and then I'm going to draw a horizontal line that passes straight through that point. Okay, I'll make it even better. There we go. I drew arrows at both ends. It extended through the whole graph, just like it's supposed to. We're good to go. Let's move on to example 3.6, which says graph y equals 3 times x and y equals 3 in the same rectangular coordinate system. Well, let's start with y equals 3, since we just talked about, horizontal and vertical lines. Well, here's a horizontal line. Well, we're going to go on the y-axis to a value of 3, right? Boom. So we're going to plot a point at that location, and then we're going to draw our horizontal line that passes through there. Well, now let's look at y equals 3 times x. Yeah, not the same because you have multiplication with x to that 3. So this equation is not the same as this equation. So let's create an xy table. All right, what x value should we choose? How about -2, -1, 0, 1, and 2? You can choose those if you want to with me. Now, we have the equation y equals 3 times x. So how do we find the y values? Well, plug in the x values that we know. So we'll have 3 times -2, and then 3 times -1, and then we continue the process. And this will spit out our y values. 3 times -2 is -6. One second. Here we go. 3 times -2 is -6. 3 times -1 is -3. 3 times 0 is 0. 3 times 1 is 3. And 3 times 2 is 6. So we've got our x, y coordinates, and we're going to plot them. Here I go. -2, -6 is located here. -1, -3, 0, 0, 1, 3, and 2, 6. So those dots that I just drew look like they go in a very straight line, and so I'll draw a straight line through them and then put arrows on both ends. And now we have just graphed two linear equations on the same coordinate system. Those two linear equations are y equals 3x in blue and y equals 3 in red. Moving forward, let's discuss how to find x and y intercepts. All right, so finding x and y intercepts, let's define what they are. So the x-intercept is the point a comma 0 where the line crosses the x-axis, and the y-intercept is the point 0 comma b where the line crosses the y-axis. If we look at a graph, looking at the x-axis, we ask where does the line cross the x-axis? And the answer is right here. All right, so the x-intercept. In this case, x-intercept, it's located at 4, 0. That's its location in space. Okay, so that's how we'll write it. Now, what about the y-intercept of this graph? So the y-intercept is located, go to the y-axis and kind of scan the y-axis. Where does the line cross the y-axis? Well, that's at a value of 2, at a height of 2. So we're going to write the y-intercept is 0, 2. Why did I write 0, 2? Because the x value on the y-axis is 0 and the y value is 2. All right, so there we go. You now can look at a graph and find the x and y intercepts from that graph. Now, a question comes up. What if I don't have the graph and all I have is an equation? How do I find the x and y intercepts from an equation if I don't have the graph to look at? And so that's this next part. So I'm going to explain how to find the x and y intercepts from the equation of a line. Well, to find the x-intercept, set y equal to 0 and solve the equation that now results for x. And then it's opposite for the y-intercept. To find the y-intercept, set x equal to 0 and solve for y. I'll show you how this is done in example 3.8 with this equation. So our goal is to find the intercepts for this equation, 2x plus 4y equals 8. So let's begin with the x-intercept. And we're going to let y equal 0, right? Like to find the x-intercept, let y equal 0, which means we're going to write our equation, 2x plus 4 times, when we get to y, we turn it into 0, right? And that equals 8. So I just wrote my entire equation, 2x plus 4, but I got to y, and I set it to 0, and it equals 8. Now I can solve the equation for x. Now what's great is this will fight and die, right? 4 times 0 is just 0. That'll disappear. And so I get 2x equals 8. And now I divide by 2, and I have found that x is equal to 4. 8 divided by 2 is 4. Okay? So I know that my x-intercept is located at 4, 0. Now let's do it for the y-intercept. I'm going to do it on the right-hand side here a little bit, taking up a little space. So for the y-intercept of that same equation, I'm going to let x equal 0 and solve it for y. So when we write the equation, we would have 2 times 0. I made x become 0, plus 4y equals 8. And now this 2 times 0, it cancels, right? Because 2 times 0 is 0. And I get 4y equals 8. 4y equals 8. And now I divide by 4. And I discover, wait, y equals 8 divided by 4, which is 2. And so the coordinate value there would be 0, 2. 0, 2. There we go. We have now found x and y intercepts from an equation, specifically this equation right here. You could try this on the right-hand side for yourself. This is a great one for students to try. Let's move forward. Graph a line using the intercepts. So we can now that we know how to find intercepts, we can graph a line with using the intercepts instead of by creating an XY table like we did in previous examples. So here's how you do it. Step 1, find the x and y intercepts like we just did above. Step 2, find a third solution to the equation. Step 3, plot the 3 points and check that they line up. And step 4, draw the line. Great. So example 3.9 says graph negative x plus 2y equals 6 using the intercepts. Let's begin with the x-intercept. Well, we're going to set y equal to 0 in the equation to find the x-intercept. So I'm going to write the equation negative x plus 2 times 0 equals 6. I'm now going to solve this equation for x. So the 2 times 0 will cancel, and I get negative x equals 6. And then I divide by negative 1. And we find out x equals negative 6. Okay, so here is the location on the x-axis of the x-intercept. So that's a location of negative 6, comma 0. I can plot it on the graph. So I know that my line will pass through that x-intercept. We should try the y-intercept now. So for the y-intercept, set x equal to 0 and solve for y. So I have negative 0 plus 2 times y equals 6. And yeah, this stuff will cancel. And so I just have 2y equals 6. I'm going to divide by 2, and I find out that y equals 3. Well, that's 0, comma 3 as a coordinate. So I'm going to plot 0, comma 3 on the graph. There it is. And I now have 2 points. And to be honest, you only need 2 points to be able to graph a line, because you just put a straight line through those 2 points, and it would look like this. There you go. So we have now graphed the straight line that passes through the x-intercept and the y-intercept. If you wanted to, you could work on finding a third point in space using an XY table, plugging X values in and finding their Y value. Here, let's go ahead and try this again in example 3.10. We are going to graph 4x minus 3y equals 12 using the intercepts. So we begin with the x-intercept, and we write our equation setting y equal to 0. So I have 4x minus 3 times 0 equals 12. We've set this y value equal to 0. And now we solve it for x. So, this stuff cancels, and we get 4x equals 12. And we divide by 4, and we now know that x equals 3. We found the x-intercept. We can write that as 3, comma 0, and then plot it on the rectangular coordinate system. Now let's move on to the y-intercept. So writing the equation, I would write 4 times 0 minus 3y equals 12. All right, what did I just do? I took this equation and I replaced x with 0. Now it's time to solve for y. So this stuff cancels, and I'm left with negative 3y negative 3y equals 12, so I'm going to divide negative 3 from left to right. And I now know that y is equal to negative 4. 12 divided by negative 3 is negative 4, and so the point in space would be 0, comma, negative 4. That's the y-intercept, and I can plot it on the graph, negative 4. Now I can draw a line that goes through these 2 points. And let's go ahead and draw that line. Okay, passes right through those points, and we've got it. We have graphed a sketch of that line. Let's go ahead and try one more time. And this is example 3.11. graph y equals 5x using the intercepts. So again, I say, well, I want to find an x-intercept, so I'm going to let y equal 0 and solve for x in my equation. So looking at this, y equals 5x, I'm going to make y 0, and it will look like this. 0 equals 5 times x. And now if I solve for x, I would divide 5 from right to left, and I would find out, wait, that's x equals 0, right? X is 0. 0 divided by 5 is 0. And so my x-intercept is located at 0, 0. That's the origin. Okay, and now I try this again for the y-intercept. And I write my equation setting x equal to 0. So for a y-intercept, let x, the opposite variable, equal 0. And so I write y equals 5 times 0. And, well, 5 times 0 is just 0. So I get a resulting equation that says y equals 0. I have solved for y, which means, well, the y-intercept is 0, 0, which is the same point as the x-intercept. In fact, whenever the x-intercept is 0, the y-intercept is also 0, because that's where the line passes through. Now, let's think about a couple other places, since the x and y-intercept were both the same point. A couple other places on the graph. Well, if I input certain x values, I can get y values out. Like, what if I made x 1, right? What if x is 1? What is y? Well, y would be 5 times 1, which is 5. So when x is 1, y is 5, I can plot that point. I could also think, well, what if x was negative 1, right? What if I made x negative 1? Well, then y would be 5 times negative 1, which is negative 5. And so I would plot the point negative 1 comma negative 5, and I would have some more points. And so I can draw a straight line through that stuff, and of course I extend it all the way to the end of the graph on both ends, and I put arrows. And we have now learned how to graph a line using the x and y intercepts. Yeah. So this is an important skill. In fact, x and y intercepts aren't just critical for linear equations, they'll be critical for many other equations that we learn about in the future, not just linear equations. So this has been lesson 3.1, and I hope that you were able to understand more than ever about graphing linear equations on the Cartesian coordinate system, the rectangular coordinate system. I hope you have a wonderful day.